Miscellaneous exercise of integration 7. Question number 19. Sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x we need to integrate. It looks like a bit difficult question. But when you do this question, I want you to remember that sin inverse x plus, one of the inverse trigonometric formula, sin inverse x plus cos inverse x is equal to pi by 2. We have two more formula, tan inverse x plus cot inverse x also pi by 2. Cosec inverse x plus sec inverse x also pi by 2. But we need only this over here. What I am going to do is in the denominator sin inverse root x plus cos inverse root x, I will write it as pi by 2. And numerator, this cos inverse x, I will write as pi by 2 minus sin inverse root x. So that the question will become smaller. So I will write like this: sin inverse root x minus pi by 2 minus sin inverse root x divided by pi by 2. This pi by 2 I can write 2 by pi into, if you open the bracket, minus minus plus sin inverse root x. That and this when you add, you will get 2 sin inverse root x. Then minus pi by 2. It comes like this. Now, I will multiply this 2 by pi inside. So, I will get a 4 by pi sin inverse root x minus pi by 2. This will become 1. So, to integrate this question, it is enough to integrate the following step. That means if you integrate this one, this will be enough. So, integral of 1 we know. So, therefore, we will write like this: 4 by pi integral sin inverse root x minus integral 1 dx. This is also dx is there, 1 dx. So, this will be 4 by pi integral sin inverse root x dx minus x. We will call this as equation number 1. This integration, we will call this as equation number 1. Now, what I do is I will integrate this part alone. I will integrate sin inverse root x dx. How do we integrate? What I do is I will do a substitution. Still now it is only inverse trigonometric formula and adjustments we reach over here. Only one I integrated. This one became x. The rest as it is. Only adjustments we made. Now sin inverse root x, how do we integrate? This is the second part of this question. This, once you get this answer, you can attach here, then we are done with the integration. So how do we do is, we will put, to get rid of this root, what I do is I will put x as sin square theta. If you put x as sin square theta, then dx I need to change. So then dx will be 2 sin theta cos theta d theta, or dx by d theta is 2 sin theta cos theta d theta. So dx will be equal to sin 2 theta d theta. Now this will become integral sin inverse root x will become sin inverse root of sin square theta, and this will be sin 2 theta d theta. Now this will be sin inverse square and square root, it's cancelled, so it will be sin theta sin 2 theta d theta. This is the angle, this sin theta, sin inverse sin theta. So this will become theta, theta sin 2 theta d theta. Now we have two functions. Theta is an algebraic function, this is a trigonometric function. So by parts I will do. So first function into integral of second. Sin 2 theta integration is minus cos 2 theta by 2 minus integral of, then theta with respect to theta will become 1 minus cos 2 theta by, that will be the integral of second function, cos 2 theta by 2 d theta. Now this will become minus theta by 2 cos 2 theta minus minus plus, then cos 2 theta by 2. It's cos 2 theta by 2, that 1 by 2 is here. This will become sin 2 theta by 2. So integration is over. Once again, this first function into integral of second minus integral of derivative of first function into integral of second function. This minus minus will become plus. Then 1 into cos 2 theta is cos 2 theta. This 1 by 2 I keep it outside. Cos 2 theta integration is sin 2 theta by 2. So this integration is over. So now we can comfortably put it back here, right here in this equation number 1. So we will reach an answer like this. We will write like this. We will be writing like this as minus theta by 2. Before that there is a 4 by pi. 4 by pi minus theta by 2 cos 2 theta plus this 1 by 2 and this can be written as 4. So 1 by 4 sin 2 theta. Then this minus x plus c. This is, we can complete the integration like this. But if you look at the textbook, the answer will be, okay, we have to, of course, replace this theta. What was theta? Theta, x is sin square theta. Therefore, from here, what I can write is sin square theta. Sin theta will be root x. If x is sin square theta, sin theta will be root x. So, theta will be sin inverse root x. That I need to replace. Now, one thing I wanted to say, if you write a sin inverse root x in place of theta, you will get an answer. But in textbook, the answer will look different. They use the formula sin inverse of sin theta as theta. So, that is possible only when you have sin theta. I have here sin 2 theta. Therefore, I cannot directly apply that. I have here cos 2 theta. So, I am going to change this cos 2 theta and sin 2 theta into sin theta by using the formulas. What formula means? Sin 2 theta can be written as 2 sin theta cos theta. Then that cos theta can be written as using 10th standard formula root of 1 minus sin square theta. This cos 2 theta can be written as 1 minus 2 sin square theta. So, look at that trigonometric variation. What we do is, I will write it like this. See, what I write is, I will write like this, 4 by pi minus theta by 2. This I will write as 1 minus 2 sin square theta. What did I write? Cos 2 theta is 1 minus 2 sin square theta plus 1 by 4 sin 2 theta can be written as 2 sin theta into cos theta. That cos theta I will write as root of 1 minus sin square theta minus x. So children, see, if you look at, you will see everywhere sin only. Everywhere sin. So I am going to do replacement. Now I will write this as 4 by pi minus theta by 2. What is theta? Theta will be sin inverse root x by 2 into 1 minus 2 sin square sin inverse root x plus 1 by 4, and this 1 by 4 and 2 when you cancel, you get here 1 by 2. 1 by 2 sin inverse root x. In the place of theta, I put sin inverse root x into root of 1 minus sin square sin inverse root x minus x. Now, you see, this I will write as 4 by pi minus sin inverse root x by 2 1 minus 2 sin of sin inverse root x is root x. Sin square means you will get 2 times root x into root x. So it will become 2x. Once again, sine inverse sine inverse root x is root x, but square is there, therefore 2 times root x into root x, it will be x, plus 1 by 2, here sine inverse, here no square, so just root x will come. And the next step, you will have the same way. Here you will be having root of 1 minus sine square sine inverse. In this fashion, it will become x. So minus x plus c. So this is how we reach the final answer. Okay, 4 by pi minus sine inverse root x by 2. If you want, you can multiply this 4 by pi inside. That is possible with you also. You can do further simplification wherever it is necessary. But this is how we reach. Children, you have one place you have confusion that comes is how to replace theta. How do we reach this answer? That what you need to do is, you need to remember this cos 2 theta converting as 1 minus 2 sine square theta. Sin 2 theta you convert as 2 sin theta cos theta. And that cos theta further you can write as root of 1 minus sine square theta. Then you will be able to use the sine of sine inverse x will become x. This formula can be used. This is possible with the principal domain, and that is done in inverse trigonometric functions. So using that idea, we will be able to get this answer. Okay.